Welcome to 3D Time, from Transportation to Physics. My name is Ralph Gelman, and this is Part 4, Kinematics II. What is displacement? Well, it's the difference between two places in space. It's the vector difference, and we'll use the letter R, boldface. An example would be a car travels east 50 kilometers and then travels north 25 kilometers. So displacement is the dashed arrow in the triangle to the right. That means it's the length of the most direct motion as well as the distance. Now, what is distimement? Well, this is a new word that we're using. It's the difference between two places in time. And it's a 3D vector difference, and we'll use the letter W in bold. For example, a car travels east for 30 minutes and then travels north for 30 minutes. Then it's the dashed arrow in the diagram to the right. So it's the time and direction of the most direct motion. And as we explained before, the direction can be in space or in time. What is velocity? Well, velocity is speed with the space direction. So it's the change in displacement over change in time, or delta R, bold, delta T. So it's a 3D vector. It has magnitude and direction. For example, a speed of 80 kilometers per hour going north. And we'll represent it by a boldface V. And an instantaneous velocity can also be defined as dr, bold, over dt. Now, what then is pace with direction? So we're using a new meaning of an old word, legerity. Legerity means lightness in movement. And we're going to use this to mean pace with a time direction. So it's the change in distimement over a unit length. And we'll use the delta W, bold, over delta S. So legerity is a three-dimensional vector. It has magnitude and direction. For example, 12 minutes per kilometer going north. And we'll represent it by a boldface letter U. An instantaneous legerity can also be defined as dW, bold, over ds. So remember that boldface W means 3D time. Here's an example. A car travels east for 50 kilometers and then for 30 minutes. And so the velocity is 50 over 30 in kilometers per minute. And to make that per hour, we multiply times 60 minutes per hour to have 100 kilometers per hour going east. The legerity then is the inverse. It's 30 over 50 minutes per kilometer, and then 60 seconds per minute to convert it to 36 seconds per kilometer going east. So these are equivalent, different ways of representing it. We'll say then it travels north for 25 kilometers for 30 minutes. So the velocity in this case is 25 over 30 kilometers per minute times 60 is 50 kilometers per hour going north. And the legerity is the inverse, 30 over 25 minutes per kilometer, and then times 60, it's 72 seconds per kilometer going north. Now if we compare these two, we have 3D space on the left with units in kilometers. And we have this triangle diagram with the displacement in red. And then on the right, 3D time with units in minutes. And again, the distimement this time in red. So like the maps that we saw before, space and time are different. They look different because they are different. What is acceleration? Well, it's basically going greater or less in distance per time. So it's a change in velocity per unit of time. The average acceleration then is, we'll use bold A, a delta V over delta t. And an instantaneous acceleration can also be defined as dv dt. So acceleration is a three-dimensional vector. And its units are things like meters per second again, so that's meters per second squared. We're going to use the word expedience here. What is expedience? Well, we know that to expedite means to make something happen in less time. So if an order is stamped expedite, that means it should take place in a smaller amount of time. So expedience then we'll define as less or greater amount of time per distance. So it's the change in legerity per unit of length. The average expedience then, we'll use the letter B in bold, is the change in U, legerity, over the delta S, the unit length. And an instantaneous expedience can also be defined as du bold over ds. So expedience is a three-dimensional vector, and its units are seconds over meters per meter, or seconds per meter squared, or something like that. Now, we're going to briefly look at equations of motion. In three-dimensional space, these are standard equations in physics. I'm not going to derive them here. They show the ways of getting velocity, the position, and the acceleration. Well, we can define similar equations in 3D time. And they look very similar because they have the same form. And the method of deriving them is quite similar as well. But the point is that they're not exactly equal. Unlike the pace and the speed, they're not inverses or anything like that. You can't get directly from one to the other, but they are similar in form. What's the conclusion of this kinematics lesson? Well, we've defined velocity and legerity, then displacement and distimement, and acceleration and expedience. So again, this is just a different way of looking at motion. And hey, 3D time does kinematics.